Calculus, here we are looking at sample test 119 through 27. We are still in the non-calculator multiple choice. And it begins. So number 19, we take a look at this one and it says, well, that looks pretty easy. Oh, whoa, what's going on here? Approximated 3 inscribed rectangles. First, inscribed, you guys, that really means inside. Of equal width on the x-axis, then the approximation is, oh, alright, well, I think we need some pictures. So let's make a table from 0 to 6. So if I have x and, y, from 0 to 6, so 0, 1, 2, 3, 4, 5, and 6. So I plug in 0, that would be 2. Why am I doing this? I want to see a picture because I want to see what's happening so I could draw these rectangles. I plug in 1, that would be 1 minus 2 plus 2, which is really just 1. Okay, well, let's plug in 2. That'd be 2 minus 2 plus 2. Well, that would be 2. All right. Let's plug in 3. That's 9 minus 6. That's 3 plus 2. Well, that's going to be 5. Plug in 4. That's 16 minus 8. That's 8 plus 2. That's 10. And then plug in 5, that's 25, minus 10, that's 15, plus 2, that's 17. 6, that's 36, minus 12 is 24, plus 2 is 26. Alright, so I'm going to do a basic plot here. I'm going to sketch it, but it's still going to be decent. And we're going from 0 to 6, so we start at 0, 1, 2, 3, 4, 5, 6, and we're going from, ooh, this is pretty crazy, from 1 is my lowest number all the way up to 26. I'm going to kind of just zoom off the top. Let's go like to 20. So we'll go 5, 10, 15, 20. So we got like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And there we go. 26 is up here, way up here, at the top, way up there. Okay, let's plot this now. So 0 or 0, 2. So we start here, then 1, 1, then 2, 2. Let's plot these in a different color here. So we got 0, 2, then it drops down, then we go up, and then at 3 we go all the way up to 5. Woohoo! Look at that. Then at 4 we go up even further all the way up to 10. And 5 is 17. About here, I guess, maybe a little lower. And then this one's 26 all the way up. Okay, so we have this curve looking thing. So I got to make 3 boxes, 3 rectangles. But here's some keywords. Equal width. 3 of them split between 0, 1, 2, 3, 4, 5, 6. So that means I'm going to split it here and here. So there's 3 boxes. They're each 2 wide, 2 units wide. Okay, so how tall would they be? Well, for this one to be inside, the lowest point is right there at 1, 1. So this has a height 1 and a width 2. So that first box is actually worth 2. So let's say we got box 1 plus box 2 plus box 3. The first box is 1 by 2, it's worth 2. The second box, it goes, the lowest point is right here because it's got to stay inside this curve. It's 2 units tall and 2 units wide. So that's going to be 2 units tall times 2 units wide. It's really 4. This is just like 2 by 1. The other box, because how do I find the area of a box? Is just length times width. It goes, 4 looks like the lowest point here, and then it goes across. And how tall is that? Well, the height of this box is 10, and the width is 2, so it's going to be 20. This other one was 4, and this was 2 right here. So this is 10 by 2. So we got 2 plus 4 plus 20 equals 26. The answer is B. What? Like for real? Yes, it is. That's exactly what it was. Because it's the approximation says inscribed, and that means that the rectangles have to be inside. Ooh. All right. So what's next? Number 18, number 19, number 20. Ooh, slope field. We actually covered this one in class specifically, but let's go over it just a little bit more. In reality, for you guys, this stuff over here is actually way down there, but I have it on my screen a little bit different. Okay, so I look at this slope field, and look at this. I noticed that I got negatives up here, I got positives down here, and I got zeros, as in flat. Because these are slopes. So then it's asking me what derivative matches these slopes. Okay, so one thing that I know is that when y is up here high, it's going to be, so if y is big, greater than something, the slope's negative. And if y is less than something, then it's positive. But what was it right here, right in the middle? What would we say? That looks like it's at about y equals 1. So when y equals 1, I should get 0 in my derivative. Well, let's see what happens. Well, I can't even do that in this one, so that one's out. For b, if I were to substitute 1 in for y, that's just x minus 1. And I could get 0, but I have this extra x, and that's kind of throwing me off. Because what if that was like 5 for x minus 1? Then it's not 0. But at 5, 1, which would be like right here, the slope is still 0. So that's out. Similarly, C and D would also be out. Why? Because they have x in it. X, x, x. X doesn't matter. It's all about the y. Because whether our x is negative over here or over here, it's the same all the way across. Look at these slopes. All the way across. They're the same. Alright, so then that leaves E. And guess what? 1 minus 1 equals 0, which means when I plug in 1 for y, I get 0 for the derivative, which means I get a flat slope, which means I get this picture. Now, if I wanted to be really anal and check the other ones, I could. For example, these values up here, when y is greater than 1, let's say like up here at, what's this, 1, 2, 3, 4, 5, 6, at 6, that would be 1 minus 6, which would be negative 5. The slope is negative 5. And down here, like 1, 2, 3, 4, 5, 6, 7, at negative 7 for y equals negative 7. The slope equals 1 minus negative 7, which would be 8. That looks good, this looks good, and this looks good. It matches. Number 21. Alright, in number 21 it says for all real numbers x, f prime of x, in other words first derivative, is less than 0. Alright, before I go any further, I want to break that down. What the heck does that mean? It means f prime of x is less than 0, Mr. Brother. No, what does it mean in words? Oh, so this is negative. Which means if f prime of x is less than 0, if it's negative, that means that slope is negative. That means that we should be going down like this. So that immediately cancels out B and A. Those are gone. And D. Ooh, so I got options, either E or C, because both of these start high, end low. They start high, they end low. Alright, next it says, for all x, not just a few, but all of it, f double prime of x is greater than 0. What does that mean? Second derivative. Well, second derivative is telling me about concavity. So that really means that it's concave positive or concave up. Concave up, which would be E. Why? Because this is concave up, but then it's concave down. And that's not okay. Can't just be partially correct. You have to be all correct, like this one. Alright, next, number 22. Here we go. So I have a derivative. It's given. Boom, right there. Then it's asking for this second derivative, which really just involves some interesting product rule and implicit differentiation. So I have an A here, I got a B here. I know that this is going to be A B prime plus B A prime. Okay, so A B prime. A is x squared. B prime, what's the derivative of y squared? Well, it's 2y dy dx, that's what it is. And then BA prime, that's going to be y squared times 2x. Now I don't see anything down here that says x squared 2y dy dx plus y squared times 2x. But, check this out, dy dx. Do I even know what that is? Yes, I do! It's right here. Dy dx was given to me, so I got to substitute that back in. So I'm going to have x squared 2y times x squared y squared plus y squared 2x. Alright, now let's simplify. X squared x to the fourth. Y to the first times y squared is y to the third. And this 2 is out front. So I have 2x to the fourth y cubed. At this point, I could probably just stop and be done because I think there's only one that matches. It looks like it's going to be E. Let's double check though. If we were to write this, alphabetical and numbers first, then that would be 2x to the first, y to the second. Ding, ding, ding. E is a winner. Number 23. Ooh, this one's interesting. It's easier than you would think if you do the algebra first, because I see something, I hope you see it too. I see multiple numerators, one denominator. So I'm going to first split this up. Pardon me, e squared, I'll still have this 4, and then I'm going to have a x over x squared minus x cubed over x squared dx, of course, applied to all of this. That'll give me 4 times the integral from 1 to e squared of 1 over x minus x dx. Let's take the antiderivative of each of these terms individually. Well, the antiderivative of 1 over x is natural log of x. And the antiderivative of x to the first is really x squared over 2. We're going to multiply that by 4. And evaluate it from 1 to e squared. So we got 4 times whatever this answer is going to be. Well, let's figure out what it would be. That's going to be natural log of e squared minus e squared over 2. That's the top piece. If I plug in the top, f of b. Now minus f of a, capital F of a. We would have 1. Natural log of 1 minus 1 squared over 2. Alright, so let's simplify some stuff. First of all, natural log of 1, that's 0. That's gone. Minus minus, that's really plus. So this is plus 1/2. Then we have natural log of e squared, which is really just 2. And e squared over 2 minus e squared over 2. And you might be thinking, I don't have that answer anywhere over here. That's because you still have to multiply by 4. Let's distribute this 4 and then start simplifying. That would give me 8 minus 2e squared plus 2. Or in other words, is that it? Nah, something's missing. That's right. See how this is e squared? Yeah, I was thinking it's e, and it is e. But then I take the e squared and I plug it into x squared, and that's really e squared squared, which is e to the 4th. So this is e to the 4th. And that gives me 10 minus 2e to the 4th. Check done, it's e. That's a lot of e's. I feel like I've picked that a lot of times. More than I would have expected. Number 24. The functions f and g are piecewise linear functions whose graph are shown above. If h of x equals f times g of x, then what's h prime of 3? Oh, all right, here. that means that h prime of x, alright, now we got derivative, is going to be, like ab prime plus ba prime, which is f of x times g prime of x plus g of x times f prime of x. So h prime of 3 is really f of 3 times g prime of 3 plus g of 3 times f prime of 3. Alright, so f of 3. What's f of 3? Well, I go over here. Here's f of x, and f of 3 is 1. Well, that was easy. G prime of 3. Think slope. What's the slope of g at 3? Well, here's g, and then I go to 3. There it is. What's that slope? That's the slope of, looks like up to over 2, so 1. So that's also 1. That was pretty easy. G of 3. G of 3 is right here at 3. F prime of 3. F prime of 3 is this slope. Okay, so, well, there's that slope. That means that it's, well, let's see how low this goes. It looks like it intersects here and here. That slope is a rise of 1 and a run of 3, so that's going to be negative 1/3. Negative 1/3. So that's 1 plus 3 and 1/3 is really negative 1. 1 plus negative 1, it's 0. Oh, that's crazy. 0. Check. Keep on going. Keep on trucking here. Number 25. Which pair of functions is the limit of as x goes to infinity of f of x over g of x equals 0? Alright, so this is kind of some knowledge about growth here and some numerical values. So if we want this to be true, that means that the top has to be smaller than the bottom, and it has to be bigger. It has to grow faster. So let's rewrite each of these. So if I look at the first one, f is on top, so that means it's going to be e to the x over x squared. The next one would be e to the x over natural log of x. After that, we would have natural log of x over e to the x. Then we got x over natural log of x, and then 3 to the x over 2 to the x. Well, for sure e is out, because 3 to the x and 2 to the x, 3 is bigger than 2. X over natural log of x, so x does this. This would be x. Natural log of x does this, and e to the x does this. This is the big one. This is the little one, and this is the middle one. X to some power n, let's say. Well, which one of these has a bigger one in the bottom? It looks like it would be C, because we got a little natural log on top and then e to the x on the bottom. That's a lot of that. It just has to do with common sense on the shape of a graph, knowing that natural log kind of curves, but then it slows down. It doesn't really plateau, but it definitely slows down, while e to the x accelerates off into space. That's why we would have C as our answer. Let's look at number 26. Let this be the function. What is the value of negative 2 to 1? Ooh, this is kind of weird. Here's why it's weird. It's split, which means we have to split this. It's going to be the integral from negative 2 to 0 plus the integral from 0 to 1. Split it at 0. Because on the left side of 0, it's going to be x times whatever this f of x up here is. So it's going to be x times, on the left, this would be the left one, so that's the first one, times x. And the second one is going to be x times the right one, which is x plus 1. So we'd have x squared from negative 2 to 0. Then over here we're going to have plus the integral from 0 to 1 of x squared plus x. Both easy to do, but still kind of a little complicated because we got to do each one separate. So the first one becomes x cubed, and we're evaluating that from negative 2 to 0. Well, you plug in 0, that gives you 0 cubed, minus, plug in negative 2, oops, negative 2, oh, it's not just cubed, it's over 3, x cubed over 3. I knew there was a fraction in there somewhere. So that would give me negative 8 over 3, but then a negative 8, which is going to be 8/3 for the first one. Now for the second one, it becomes x cubed over 3 plus x squared over 2. We're evaluating that from 0 to 1. If we plug in 1, that becomes 1/3 plus 1/2 minus what when we plug in 0, so that becomes 0/3 plus 0/2. Those are gone, so we really just have the 1/3 plus 1/2. So we got 8/3 plus 1/3 plus 1/2. So we're adding both parts. Well, 8/3 and 1/3, that's 9/3. That's convenient, plus a half, which is really 3.5. Or 7/2. D. I think we got one more in here. Yes, we do. Number 27. It says the average value of the function f of x equals cosine half x is on the closed interval is, keywords, average value. Average value. Okay, average value tells me this. Average means you add up a sum. You add up a sum, and then you divide by the number of things, of whatever. So that's like saying take the integral from, in this case, negative 4 to 0 of the function cosine of 1/2 x dx. But then you got to divide by that range from negative 4 to 0. So you start at negative 4, you end at 0. That really means that you have a range of 4, because that distance from negative 4 to 0 is 4. So that's where we're probably getting this 1/4 here, or maybe this negative 1/4. Well, let's see what happens. This is a u substitution integration, because the antiderivative of cosine of u du is sine u. And in this case, u equals 1/2 x. So du dx equals 1/2. Or 2 du equals dx. So in reality, I would have the integral of cosine of u du. What's the antiderivative of cosine u du? It's just going to be sine u. Well, in this case, oh, but we got a 1/2 in here. Don't we? No, we have a 2. So we're going to have this 2 there. So it's going to be 2 times sine of u, which is 1/2 x. We're evaluating that from negative 4 to 0. Then we're dividing all of that by this 4 right here. Let's keep simplifying. Plug in negative 4. So we're going to have 2 times sine of 1/2 of 4, negative 4, which is really negative 2, minus 2 times sine of 0, which is really 0. 0 times 2 is 0, so that's gone. But then we're dividing this by 4, the whole thing. Well, sine of negative 2 oh, that's what's happening. They're playing on the idea that sine of negative x is really negative sine of x because it's an odd function. Okay, so we're going to have, this is the same as negative 2 over 4 times sine of 2. Or negative 1/2 sine of 2. Wow, that's some crazy pre-calculus thrown in there. The answer would be A. But very close second would have been an E. With this negative, that's a tricky one. Very tricky, tricky, tricky. Alright, so that's that. Let's go ahead and wrap up this video. Preview of what's coming next. We're going to be looking at numbers 29 through 36. And you're probably saying, 28? Where's 28? Well, we're going to skip it. We'll go over it in class. That's all. Have a good night. Thank you. Bye.